Okay, this is an integral from MIT Integration Bee 2017, problem number 6. We have the integral from infinity to 1 of dx over x squared plus 1. First, it seems to be pointing towards us doing a trig substitution, and I did that and it worked fine, but what I actually wanted to do is just multiply this x inside of the integral and see where we're at. So when we do that, we just get in the denominator x cubed plus x. I feel like they wrote it this way, maybe a little bit leading us, but when we do this, we have our option to factor it out how we want. And I do it this way because instead of factoring out an x, what I want to do is factor out an x cubed from our denominator. So what we're going to have, factoring out x cubed, doing it this way, we're going to have 1 plus x to the minus 2 dx in the numerator. But then I'm just going to bring this into the numerator and write it as, and all I've done is rewritten this in the numerator. So from here, what we can do, I think we're set up nicely for a u substitution. If we just make this our u, I think this will work fine. So u is going to be 1 plus x to the minus 2. Then du is going to be, this part's a 0, minus 2x to the minus 3. That's pretty similar to what we have here in our numerator. What I'll do is I'll just kind of pencil in a minus 2 to make this work. But so I'm not changing the expression, we'll write a minus 1/2 in front. Now let's make this substitution. First, we need to update our bounds. Plugging a 1/2 in here. Did I say half? First, plugging infinity in here. This is 1 over x squared, so 1 over infinity, this is going to 0, but we still have the 1. So our upper bound will be 1. And then plugging a 1 in here, it's going to be 1 plus 1, 2. Then we notice our whole denominator, our whole numerator is this du value. So we're going to have du on top and u on the bottom. And one thing I think I'll do, I think I'm going to use this minus sign to flip the bound. So we'll change this to a plus, and we'll just rewrite this as 2 to 1. So then we can integrate, very simple integral. This is going to be ln absolute value u. You just want to evaluate that from 2 to 1. We're left with half ln, I'm going to drop the absolute value, there's no need for absolute value on 2, minus half ln 1. But ln of 1 is 0, so this piece goes away, and we just left with half ln 2. If we want, we can write this as, bring the half as an exponent and write this as ln square root of 2. So that's it, pretty good problem, nothing too hard. We'll stop it there. That was MIT 2017. Problem number 6. Thanks for watching.